Okay, hey class, welcome back. In our last video, we introduced ionic compounds, which are compounds between metals and nonmetals. In this video, we're going to continue our discussion about chemical bonding with covalent compounds. Before we do that though, let me introduce you to some vocabulary words that you may or may not have been using. A molecule is a neutral group of atoms that are held together, while a molecular compound is a chemical compound in its simplest form. This means it's basically a reduced chemical formula. Well, what is a chemical formula? A chemical formula indicates the relative number of atoms for each kind of chemical or element within a compound using the atomic symbol and a numerical subscript. And finally, our molecular formula shows the types and numbers of atoms that combine together to form our molecular compounds. Now that we have that information, we can state our objective for today. Today, I want you to be able to determine the molecular formula and chemical name for covalently binding molecules. And saying that, let's dive into what we got. Covalent bonds occur when valence electrons are shared between two or more nonmetals. Okay, what do I mean by sharing? Well, this means that the valence electrons from each atom will spend time in the valence orbital of both the original atom it came from and whatever atom it is binding to. With covalent bonds, the bond energy and the amount of energy it takes to break a chemical bond depends on the length of the bond and the bond strength. Bond length and bond strength can directly correlate with how electrons are involved in covalent bonds. For example, atoms can share 1, 2, or even 3 electrons with another nonmetal. This can result in a single, double, or triple bond. Single bonds are the longest covalent bonds, followed by your double, and then your shortest is your triple bonds. The trend for bond strength is opposite bond length, so the shorter the bond is, the stronger it's going to be. In other words, your triple bond is going to be your strongest bond, while your single bond is going to be your weakest. Now, remember the octet rule. Atoms tend to be most stable when they have 0, 4, or 8 valence electrons. This tells us how likely an atom is going to form multiple bonds. We're going to keep that in our back pocket for a bit. Now, when naming covalent compounds, we're going to use prefixes to tell us how many of each atom there are. Here's going to be a list of the first 10 prefixes. So if an atom has one of itself, we're going to use the prefix mono. If it has 2, then we're going to use di. 3, tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. And 10, deca. Now that we know that, we can talk about how do we name covalent bonds. Well, our first step is, if it's not already stated, we need to write the chemical formula for the covalent molecule. Next, we fully name our first atom and shorten the name of our second atom with the "-ide" suffix. So this is kind of like our ionic compounds, except for ionics we had a metal and nonmetal. Both of these are going to be nonmetals. So our first one is going to be fully named. Our second one's going to have a shortened version with the "-ide" suffix. Our third and final step is to add appropriate numerical prefixes for each atom indicated by how many there are in the formula. So if I have hydrogen and oxygen, my formula is going to be H2O. Since I have my formula, I can now go to step 2, which is write out my full name of the first element, which is hydrogen, and then shorten my second element with the "-ide" ending, so oxygen becomes oxide, so I have hydrogen oxide. Finally, we add our prefixes to each atom. So I see that I have 2 hydrogens. So the prefix for 2 is di. So it's going to be dihydrogen, and we have 1 oxygen, so it's going to be monooxide. So dihydrogen monooxide is H2O, also known as water. When you are given a molecular compound's name and you are asked to come up with the formula, you simply just have to write the chemical symbol for each element within the molecule, then add each subscript equal to the prefix that is paired with. Also, if there's no prefix paired with the first element, we can assume automatically that that is going to be a 1 as your subscript. For example, if I have carbon dioxide, carbon and oxygen are both nonmetals, so this is a molecular compound. If we are asked to write the molecular formula for it, Then we would start out by writing our letters for each of the elements. So we have carbon C and oxygen O. Then I would add my subscripts. So first I see dioxide. Di means 2. So that would be a 2 as my subscript after my oxygen. Well, carbon doesn't have a prefix to indicate how many subscripts it has after it. Well, because it's the first element, it doesn't have to have a prefix if it only has 1. So we can assume because it doesn't have a prefix, then that is a prefix of 1. So we get carbon dioxide is CO2. I hope this video helped you out and gave you some basics when it came to covalent compounds. Keep up the good work in the class and see you next time.